actually do the flame tests in class. Basically, we sprayed a bunch of different solutions, things like sodium chloride or lithium chloride or strontium nitrate or potassium chloride, different salts that we sprayed in the flames, and they turn different colors, from reds to bright orange to violet and green, all different colors. So why does that happen? Let's talk about the chemistry behind the cool flame test colors. First of all, a little background on waves. So if a wave has low energy, that means it's got a long wavelength and a low frequency. So what that means is there would not be many waves passing by a certain point as a wave of high energy, high frequency. So this wave has a shorter wavelength. And these colors are actually great because the color red is a lower energy color and the color green is a higher energy wavelength. Okay, so again, the colors that have the highest energy are violet, blue, and green. Red, oranges, and yellows are your lower energy. And remember, this is all a spectrum, so we can't see radio waves, but they're around. Your microwave is producing microwaves. Heat is a form of a wave. And then there's the visible spectrum, which is what we can see. And then beyond that, the higher frequency waves are ultraviolet, X-ray, and gamma ray. Of course, you don't want to be unshielded around really any of these. That's why we put sunblock on, to help prevent our exposure to ultraviolet waves. And that's why you put a lead vest on when you're getting an X-ray, so that your body isn't overexposed. Alright, back to the electron world. So electrons of an atom can have different energy levels. They can be different distances from the nucleus. Electrons that are closest to the nucleus have a lower energy state than the electrons that are further away. Those have a higher energy. Electrons can jump. They're typically in their ground state. They're in one of those earlier, or the shells that are closest to the nucleus. That's the stable state. But if they gain energy, like putting it in a hot flame, the electrons can jump up to a higher energy level, and that's called being in their excited state. So how do the flame tests work? When an electron absorbs energy, it jumps to a higher energy shell, and it's unstable. What goes up must come down. So, for example, an electron might move from a 1s subshell to a 4s subshell. Eventually, when it comes back down to its stable energy level, it releases a photon of light. Depending on if that photon is in the visible spectrum or not, we may or may not see it. If it's in the visible spectrum, it's anywhere from red to violet, and that depends on the wavelength. So why the different colors? Well, depending on the height of the jump, if it's a big jump and a big fall, that's going to release a higher amount of energy than just a small jump. Because every single element has unique properties, meaning a different number of protons that are attracting those shells of electrons in tighter, or vice versa, not as many, and different numbers of shells that have electrons. This is why all the flame colors are different for every element. So again, if there's a big jump, there's a big fall, and the electron's movement would result in a release of green, blue, or purple light, and a small jump would release a low energy color like red, orange, or yellow. Final question. If a valence electron in calcium jumps from a 4s subshell to a 6p subshell, is it still calcium or has it changed? It's still calcium. You haven't changed the number of protons, which is 40 for calcium. I'm sorry, 20 for calcium. 20 protons. As long as that atom still has 20 protons, it will always be a calcium. That is it for the flame test notes.